So if you consider question number 6 on the same exercise that we were working with, which is our exercise 6, we are given this time that this EF is a tangent to the circle at C. So from the point E to F, which is this one as a tangent at the point C, and also that CDG is a straight line from C to G to D, that's a straight line. A, B, C, D are points on the circle. And also BCE is 53 degrees. That is from B to C to E, we are given 53. CBD 60 degrees. That is this angle C, B to D. The angle that we are given inside here is 60. And also ADG from A to D to G is 105. We are also indicated there. 6.1 is BD parallel to EF. Justify your, it's a question. It's a question. They are asking you, are these two lines parallel? Line BD and the line EF, are they parallel? If they are parallel, meaning to say we must, or we are supposed to have any theorem about parallel lines, consider corresponding angles, co-interior angles, alternate angles, everything from our grade 9. So you will see that these two lines, they are not, because if you are to consider alternate angles, create a Z like this, you know that alternate angles, if you create a Z, they are supposed to be equal. But these angles, they are not equal. This angle that we are seeing here is 60. This angle is 53 degrees. They are not equal. So meaning to say, this here is not. All right. So no, that's if you were to consider, if we were to have alternate angles, if we were to create a Z, we were supposed to have equal angles, but these ones, they are not. So alternate angles not equal on this one. All right. Alternate angles not equal or unequal. So they were supposed to be equal if truly they are parallel. We are going to see that this was supposed to be 60. This was also supposed to be 60, so that we talk of what? Alternate angles. But in this case, they are not. So means say these two lines are not. Complete the following statements. So in this case, you are supposed to answer this by filling in what is missing on these statements. The angle between a tangent and a chord is, they just ended there. They just ended there. The angle between a tangent and a chord. So this is a theorem. Remember that the angle between a tangent and a chord is equal to the angle in the alternate segment, or in the opposite segment. So that one, the angle there is going to be 6.21. So this one, it is equal to the angle subtended. All right, so it's going to be equal to the angle subtended, to the angle subtended. So the angle is going to be subtended by the chord. All right, by the chord. But when subtended by the chord, where? In the alternate segment. In the alternate segment. All right, so that is the idea there. So the alternate segment means opposite segment. So with this information, it means this angle P is going to be 53 degrees, angle between a tangent and a chord. If you consider chord BC, it creates angle at P. Also, this angle Q, angle between a tangent and a chord, if you hold this chord, it creates the angle of 60 degrees. So meaning to say this also was going to be 60 degrees using the same theorem. All right, so but as we hear, we're just answering, I'm just explaining what this is all about. The opposite angles of a cyclic quadrilateral, opposite angles, if you're given a cyclic quadrilateral, you know that opposite angles are supplementary. They add up to 180. So these ones, they are supplementary. They add up to 180 degrees. All right, another part that you're given, the exterior angle of a cyclic quadrilateral is the exterior angle of a cyclic quadrilateral is equal to the opposite interior or the interior opposite. I don't know the way that you're gonna take there. So this one is equal. They are equal, all right, to the interior opposite angle, to the interior opposite angle, or the opposite interior angle. That's the idea of a cyclic chord, all right, and the exterior angle there. All right. So the other part there was to determine angles P, whatever that we have in that order. Give reasons for your answers. All right. So in that order. All right. So let's see P. Already we said P is going to be 53 degrees. All right. So P 53 degrees. The reason that is the tan chord. All right. Angle between a tangent and a chord. So I'm just going to write in short tan chord, but this is the one that we talked about, the angle between a tangent and a chord. All right. Then we move on to angle Q. Angle Q also talked about this 60 degrees from the same theorem. We saw that this is 60, so this is going to be 60 degrees also. All right, angle V, considering angles on a straight line or considering angles in a triangle, it's up to you. So it's going to be 180 degrees. You subtract, if you're using angles on a straight line, there is a 53 degrees on the straight line. There is also a 60 degrees on the straight line. So you're going to subtract all these angles that we are seeing from 180, and that was going to give us 67 degrees. So you can consider angles on a straight line. You can consider angles in a triangle equals to what? 180 degrees. All right, that's our angle V. Then angle W, which is this one. Considering A, B, C, D, this is a cyclic quadrilateral. All these 4 points are on the circumference of a circle. So we said the opposite angles of a cyclic quadrilateral are supplementary. They add up to 180 degrees. So meaning to say, if this is 67 degrees, our angle W is going to be 180 degrees minus 60, minus 67 degrees. That was the condition, and this was going to be 113 degrees. So they were simply talking about opposite angles of a cyclic quad, opposite angles of a cyclic quadrilateral. So they are supplementary. All right. So that means this was going to be 113 degrees. All right. Angle X. How can we determine angle at X? All right, so there were so many ways, actually not so many ways, but you can use this concept here. Angle X and this angle here that we are seeing, if you consider this angle, that we can find this angle Y here. All right, because if you consider these are angles on a straight line, so you can consider finding angle Y there from angles on a straight line. So angle Y is going to be this angle from, because there are two angles there on a straight line. So it's going to be 180 minus the angle on a straight line. There is 105. Also, there is 53 degrees. You subtract these two, or just open a bracket. Then if you open a bracket like this, you add. But if you don't open a bracket, you just minus, and so on. So if you were to subtract this, meaning to say we're going to have something like 22 degrees. So this angle Y there is 22 degrees. So it means from there, you can determine angle X. Angles in a triangle, they add up to 180. So it is going to be 180 minus, like I said, if you open a bracket, you add these two angles. That is the 113 inside of the triangle. There is 113 degrees. There is also 22 degrees. So if you're to subtract this, you're going to obtain 45 degrees at the end. So this one, we are talking about angles in a triangle, all right? Angles in a triangle add up to 180. This one, we considered angles on a straight line. This is about angles on a straight line, angles on a straight line. So this is how you can attempt these typical questions. What you need is to make sure that you have your theorems and work with your theorems together. You can answer any typical question that you might be given in your examinations, in your final examinations. Let's revise as much as we can.